variable mass system. All of you are able to see my screen? It's clear? Okay. Suppose I consider there's a rocket, okay, which is moving with v and its mass equal to capital M at t equal to 0. But what is happening after some time when it is moving? It's ejecting some gas also, correct? Because of exhaust, its mass is also decreasing. So let us consider after some time that this is dm mass is released, and which is moving with a velocity v relative. With respect to rocket, it is ejecting gas with respect to v relative. So what will happen if I eject gas with v relative, this rocket? What will happen? There will be a thrust force, ft, thrust force, correct? And mass of the rocket will be now m minus of dm. Clear? Is that clear? M minus of dm. So because of this thrust force, what will happen? Velocity of rocket will also increase. So velocity of rocket, can I write v plus dv? Initially started with what velocity? V. After some time its velocity will be what? V plus dv, correct? So I'll just write the notation dm. What is dm? dm equal to, wait, somebody is joining. Yeah. So what is this dm? dm is mass of exhaust gas. Clear? What is v relative? V relative is relative velocity of exhaust gas, okay, with respect to rocket. Clear? So now what I want to find? I want to find this velocity and force at thrust force with respect to time at any time. Okay, so first I know that this velocity of gas with respect to rocket can be written as velocity of gas minus velocity of rocket. Correct or not? Obviously this will be vector. So this is the formula for relative velocity. So what is v relative? V relative will be what? V relative v gas minus v, okay, velocity of rocket initially it was v, correct? So I can write here velocity of gas equal to v relative plus v, okay? So this is the velocity of gas. Now can I apply conservation of momentum? Yes, obviously, because there is no external force, okay? F external equal to 0 in the horizontal direction, so I can apply conservation of momentum, linear momentum, okay? So applying conservation of linear momentum, if I apply conservation of linear momentum, what is the initial momentum? Tell me. Initial momentum is mv, correct? That is equal to final momentum. What is final momentum? Final momentum is momentum of gas plus momentum of rocket. Clear? Is that clear? Okay. What is initial momentum? mv. That is equal to, what is momentum of gas? dm into v relative plus v. This is the momentum of gas, okay? Is that clear? Clear all of you? Plus, what is momentum of rocket? Capital M minus dm. Capital M minus dm into v plus dv. One of the confusion you may have that, sir, why you are not taking negative? Correct. You might have confusion, sir, momentum of gas, why you are not taking negative? Because it's coming this side. See, if you have any time seen any jet which is flying in the sky, it's not that gas is going backward, okay, because velocity of rocket will be so high. So don't worry about that, because relative velocity I have taken na. If it is coming back, automatically the sign will come negative. Okay, is that clear? So I can write from here mv equal to dm into v relative plus dm into v plus mass of rocket was what? M minus dm, and velocity was v plus dv, because velocity of rocket will increase because of thrust force. So you just solve this. Capital M into capital V minus capital M, not minus, plus capital M into dv, correct, minus dm into v minus dm into dv. Is that clear? Is that clear? Now you check this. Capital MV cancel, DMV cancel, this will be 0. Why? This will be very small, because if you are multiplying two small quantities, it will be even more small. You multiply 0.1 into 0.1, so you get 0.01. so dm is also small, dv is also small, so together this will be very small, so I am neglecting. Okay, just after t plus dt time. Okay, is that clear? So now what I can write? I can write dm minus of dm into v relative equal to what? Equal to, I am left with this only one term, correct, m dv, correct, m dv. Okay, is that clear? Is that clear, all of you? Okay, so what is v relative? Minus of v relative into dm by dt equal to what? M dv by dt. Just differentiate v relative into dm by dt. Dm was there, so you write v relative minus v relative dm by dt equal to m constant, okay, m constant into dv by dt, correct. What is thrust force? Thrust force is what? M into dv by dt, correct. Is that clear? Obviously m into minus dv by dt, that is the thrust force. So what is the thrust force? Thrust force here will be v relative into dm by dt, rate of change in momentum of that exhaust gas, that will be the thrust force. It's clear? See, when the rocket is moving forward, so here exhaust gas is moving at a speed of v relative, and rate of loss of exhaust gas, that is dm by dt. How much mass of gas is coming out? So what is force? Force, you can write v into dm by dt. When velocity is constant and mass is changing, so you can write force in this format, correct. So thrust force, you have to remember this, correct. Thrust force equal to what? V relative dm by dt. Is that clear? So this force will be positive. Why? It will act forward direction. Thrust force on the rocket, on this rocket, thrust force will be positive. Is that clear? Is that clear? Which one? Yeah. M dv by dt, I told thrust force Ft equal to m minus of dv by dt. Clear? This is the thrust force, because thrust force will be opposite to dv by dt. Clear? Thrust force will be in the forward direction. Okay. Yeah. So now I'll tell you one thing. If mass m is added, so this is exhaust, so mass is rejected. Now if mass m is added or rejected, if mass m is added or rejected from a system, if I add or reject mass m from any system at mu kg per second with relative velocity v relative, okay, v relative, then thrust force on system will be, you have to remember this, then thrust force on the system will be mu into mod of v relative. Is that clear? So thrust force I can write I can write equal to, okay, I'll send you this note today, okay, after class. Thrust force equal to v relative into dm by dt. Always you can remember. Now if mass is added, dm by dt is positive. If it is rejected, it will be negative. So based on that, it will have thrust force. Okay. So basic definition you understood for rocket. Okay. We'll also find what will be the velocity of rocket at any time. Okay. So you just need to remember this. Any doubt, anyone till now? Unmute yourself and let me know if you have any doubt. Okay. Rocket. Yeah. You want to? Yeah, I tell. How it is coming? V relative dm by dt. Yeah. So this dm by dt only mu. Correct. Mu is kg per second. See the unit? Mu is kg per second. That is only dm by dt. Okay. Clear? Okay. Rocket propulsion. Okay. Suppose I consider there is a rocket. Okay. This rocket is moving up with a velocity of u and mass is m naught, initial mass. At t equal to 0, velocity v equal to u, mass equal to m naught. This is at t equal to 0. Okay. After some time, there is a thrust force because of exhaust gas. Mass becomes m naught minus mu t after t second, okay, after t time. And there is a weight of the rocket also, w. Okay. This is at t equal to 0. This is at t second or after t second, you can write. After after t second. This is at t equal to 0 that I have written already here. Okay, clear. So mass of the rocket will decrease. What is mu? Rate of exhaust gas, rate of rejection of exhaust gas. Okay, just wait one second. Who is joining? Okay, this is rate of rejection of exhaust gas. Clear? Mu. So now can you tell me the simple Newton laws of motion equation, free body diagram equation? Can I write F net force is what? Net force is what? Ft minus W, no? One is thrust force minus W, that is net force. Or basically I can also write Ft minus weight, thrust force minus weight of the rocket equal to mass into acceleration, that is net force. Clear? Okay. So net force is m dv by dt equal to thrust force is what? Vr minus of dm by dt. See, you have to be very very careful because now the gas is rejected, that's why I took minus dm by dt. What I told, thrust force, you have to always write thrust force mu into v mod of v relative. You don't need to consider the sign of v relative, whether it is coming out or going in same direction, no need to consider that. Just put with sign this dm by dt. If mass is rejected, minus, if added, plus. Okay, so here mass is rejected from the rocket, so I am writing minus of dm by dt, correct? Minus of mg. Okay, now simple equation, what is dv by dt? Dv by dt will be vr by m, vr by m minus of dm by dt minus g. So what is dv? Integration of dv equal to vr by m minus of dm, correct or not? Because dt will get cancelled, minus of g dt. Okay, so from where to where integrate from 0 to t. Now here dm is there, correct? So dm, it is changing from m0 to m. At any time when the mass is m, that's what, no, when the mass is m, that's what acceleration is, mass into acceleration. I have written here mass into dv by dt, net force. So final mass is what? Final mass is m, initial mass is m0. So if I write here dv is changing from where to where? U to V. So I'll write V minus U equal to VR minus VR integration of dm by m. What is integration of dm by m? Medhanj, what is integration of dm by m? Yeah, correct. ln of m by m0. Okay. So this minus, I'll just put minus to the power, okay, so that I get m0 by m minus of gt. So what is v? V, you get u minus gt, v equal to u plus at you get, na? So obviously that term will be there, v equal to u minus gt, but again one additional term, it will get some additional velocity because of exhaust gas. Vr into ln m0 by m. Okay, is that clear? So this is the velocity of rocket at any time t. Velocity of rocket at any time t. Okay, after starting of its journey. Clear? Rocket propulsion, all of you. This is very simple. Okay. Okay. Clear all of you rocket propulsion? Any doubt, anyone? Tell me. Yeah. VR is relative velocity of exhaust gas. Okay. With respect to rocket. VR is relative velocity of exhaust gas with respect to rocket. With respect to rocket. This is the velocity with respect to rocket. Okay. Okay. So this is about rocket. Okay. In other also some general variable mass system also we can discuss about. What is general variable mass? You must have seen when you have anytime you have gone to airport, there is a conveyor belt, and suddenly one person is taking, another person is taking their luggage. So the mass, whatever is there on the conveyor belt, is changing. Correct? There is a conveyor belt. There is a conveyor belt which is moving with some velocity, and there are so many luggage. One person picks up, another person picks up. Now, if I consider this conveyor belt moving with some velocity, okay, so that means it needs some kinetic energy to move with that velocity. It needs some kinetic energy. That kinetic energy is provided by some electrical source. Okay. Suppose I am considering the electrical source is providing some energy E. Okay. Now when a person is taking out luggage, what will happen? The mass will decrease. Initial kinetic energy was half capital M V square. After 2-3% takes the luggage, what will happen? Mass will decrease. Suppose half small m V square. So if mass is decreasing but electrical source is providing same energy, then what will happen? Velocity will increase. Correct or not? Velocity will increase or not? But it does not happen. No, it's not that the last person who is collecting the luggage, for that person luggage is coming very faster or velocity has increased. It does not happen like that. Okay. So basically what I am doing from external source, I am providing whatever the extra force is needed, I am providing that much only. Okay. So how this happens actually? So we'll talk about that. So whenever I am talking about variable mass, generally you know that force equal to what? Force is dp by dt. And you know P equal to mv. Clear? So force can be written as m dv by dt plus v into dm by dt. Okay, this is the actual definition of force. Now if mass is constant, then you can write dm by dt 0. Then you get force equal to m into dv by dt. Simple. But here mass is not constant. Mass is also variable. Correct. So I cannot write dm by dt 0. So my force equation will be this one only. M dv by dt plus v dm by dt. This is the force equation. Tell me what will be the impulse? Impulse will be what? Change in momentum. Impulse can be written as impulse equal to integration of f dt. That is equal to what? Delta p, change in momentum. Okay. Now for a constant force, I can write f. I can take f outside integration of dt equal to delta p, change in momentum. Okay. So if it is changing from 0 to t, I can write f into t equal to delta p. All of you know this. Okay. So I'll use these two equation only. Okay, we'll solve one question. So first question, we'll solve some application. Application 1. So what is application 1? Application 1 is, suppose there is a cart. Okay, application 1 is, suppose there is a cart. This cart is moving with V0 initially. Sand is falling, okay, on this cart. Mass of the cart is initially m0, okay. Cart is moving with v0. Sand is falling at a rate of mu kg per second. Okay. So question is basically, cart is moving with v0 initially, and sand is falling at mu kg per second. Velocity, you have to find velocity of cart after t second. Question is very clear. Cart is moving with v0, initial velocity is v0, sand is falling at a rate of mu kg per second. You have to find velocity of cart after t second. Okay, consider this surface, it's moving on smooth surface. Okay, clear. Initially it's given v0 velocity, so there is no other force to stop it. Okay, so what I'll do, I'll tell you this with two method. Method 1 for solving this, I'll use this equation, force equation. Force equal to what? dp by dt, that is what? m dv by dt plus v into dm by dt. This is the force equation. Okay, correct. What is F external? External force in horizontal direction. Yeah, correct. So Fx equal to 0. Horizontal direction there is no force. So if horizontal direction there is no force, so I'll write that equation only, 0 equal to m dv by dt plus v into dm by dt. Clear? Okay, what is m? M will be equal to m0 plus mu t. After time t, m will be what? m0 plus mu t. Mu is the rate of this dm by dt, rate of falling of sand is mu, correct? Mu kg per second. Okay, so I can write m dv by dt equal to minus of v into dm by dt. Is that clear? So dv by v, you integrate dv by v, take this v this side. Okay, dt cancel, dv by, what you get? dv by v equal to minus, acha, dm by dt is mu, don't cancel dt. Okay, dm by dt is a term. This is dv by v equal to minus of mu into v, correct or not? Mass m I'll keep here. What is mass m? Mass m is m0 plus mu t m naught plus mu t. Once again, dv by dt mu v, mu into dt, mu dt. Okay, integration of dv by v equal to minus of mu dt. So integration of dv by v, if you solve this, dv by v equal to minus of mu by m naught plus mu t into dt. You have to integrate it. Okay, so dt by m naught plus mu t, so it's not a constant term, it's a term of t. So you have to integrate 0 to t, and suppose v is changing, velocity is changing from v naught to v. Okay, so dv by v will be ln v, ln I can write ln v by v naught equal to integration of 1 by m naught plus mu t dt. So you get ln of m naught plus mu t by mu. So you solve from 0 to t. If you write 0 to t, you get ln of m naught when m naught plus mu t by m naught. Okay, so if you do it reciprocal, you get ln of m naught by m naught plus mu t. So this is what you get, that is equal to ln v by v naught. Now ln cancel, v you get v equal to v naught m naught by m naught plus mu t. So this is the velocity at any time t, velocity of the cart. Okay, clear? Why? That's what you are practicing now, na? I'll tell you another method. Method 2. Don't do this. Method 2. What is method 2? Integration of f dt equal to what? Delta p. Correct? This is 0. External force is 0. So can I write p final equal to p initial? What is p final? Final mass plus final velocity equal to what? Initial mass into initial velocity. What is final mass? M naught. Final mass is how much? Tell. What is the final mass? M naught plus mu t into v final is, suppose v equal to initial mass is how much? M naught. Initial velocity is v naught. So v equal to what? M naught v naught by m naught plus mu t. Can we solve this in exam? Yeah, you have to solve this one only. That's why I told impulse momentum method is very important. Impulse momentum method. This I solved with impulse momentum method. If you integrate this ln, this is very hectic. Don't do this method. This is just to tell. You can also solve by this method also. Okay. So method 2 is better, correct? Okay. Now, in this question, what I told? There is a cart. I have given cart a velocity v naught. There is no external force. It's moving. Okay. So all of you understood? Anyone has any doubt in this question? Application 2. What is application 2? Application 2 is, first I am writing the question. A constant force F is applied on a cart. Okay, and Sand is falling. Sand is also falling at rate mu kg per second. Constant force, sand is also falling at mu kg per second. I am asking find velocity of cart after t second. Question is clear? There is a cart. Obviously this surface is again smooth, there is no force. Now I am applying a constant force F. Okay, suppose you consider this cart is pulled by some horse, okay, or something like that. Initial velocity of the cart is 0. Now at the same time what is happening? Sand is also falling. Sand is also falling at mu kg per second. This is the rate of falling of sand. Okay, clear? Sand is also falling at this rate. Okay, what you have to find? You have to find velocity of cart after time t, after t second. Okay, can you just try, all of you, and tell me the answer? Follow the impulse momentum method, try to solve it. Easy, it's not tough. Also you have to find acceleration. Also find acceleration. You have to find velocity of cart and acceleration after t second. So first you have to find velocity, second you have to find acceleration after t second. Yes. Who will tell me the answer? Mass of the cart you take m naught. Or yeah, m naught. How it will be 0? Why minus? No. Sand is falling on the cart at a constant rate. Okay. No. Yeah. You have to take from the frame of reference of cart. No. In cart, mass is adding. Yeah, correct. So you do impulse momentum method. Integration of f dt is what? Change in momentum. Not ma, ft divided by m naught plus mu t. P final minus P initial. P initial is 0. See, that's why I have given you 0. It's very easy then. P final is what? P final is mass into velocity. Mass is what? Mass is m naught plus mu t into velocity is v, f into t. So that's what I am asking now. V is what? Ft divided by m naught plus mu t. Clear? This is. Yeah. Okay, because on the cart mass is added na, sand is falling on the cart, correct? So mass of the cart after some time will increase, correct? It will be initial mass plus mass of sand. After t second, mass of sand fallen on the cart will be mu t. Okay, yeah, you find the acceleration also. Acceleration, yeah, correct. How much you are getting? Okay, no, I'll tell you another. Yeah, you have to use that rule only, but I'll tell you another method. Acceleration will be F minus mu v divided by m. Okay, how? Tell how? Hmm? How I'm writing this? सर आप कुछ भी लिख देते हो पता नहीं चलता है. How I am writing this? Okay, see, when mass is falling on the cart, you tell me, when mass is falling on the cart, okay, so this mass, if I am taking with some velocity v, I have to give some force or not this side? Yes or no? Hmm? I have to apply some force. Obviously, that force is coming from the force whatever is applied on the cart. Okay. So, what is mu into v relative? What is mu into v relative? You remember? I told you what is this? Thrust force, no? Yeah, this is thrust force. Okay. Now here mass into acceleration will be what? Equal to total force minus mu into v, thrust force. Why minus mu v I am doing? Why minus mu v I am doing? Because when the mass falls on the cart, no? When mass falls on the cart, I need to give more force, na? And if I want to maintain its velocity, I need to give more force. Because of falling of mass, what will happen? If I don't give any force, here, you consider my force is 0, this force is 0. If this force is 0, initially it has some velocity v. If mass falls on it, its velocity will decrease. Correct or not? Now how the velocity is decreasing? You are able to understand. If there is a cart moving with v0 and I throw some mass on this, what will happen? Its velocity will decrease or not? Decrease or not? That means due to this falling of mass, there is a thrust force which is backward. Is it true? Is it true or not? Yes, correct. So that's why I am writing mass equal to what? Net force minus thrust force. Net force will be what? Net force is this F minus Ft, thrust force. Ft is what? Ft is at any time when the velocity is v, I can write mu into v. V relative is v only, velocity of cart. Okay, mu into v. So I can write acceleration equal to F minus mu v divided by m. This is the acceleration. Or you can do dv by dt. You'll get same result. Okay, clear? You'll get same result. So solve this. F minus mu v by m. Yeah, that is only total mass, that is only m. Yeah, at any time that is mass. How much you are getting acceleration? You'll get F m naught divided by m naught plus mu t whole square. This is the acceleration. Okay. Okay. You solve this, put the value of v. I have got now previously v. You have to put this value of v. Okay. So then I think you get ft f m naught you will get. And mu t will get cancelled. Okay, all of you. And small m will be capital M naught plus mu into t. Okay. Application 3. All of you should solve this question. Okay. Application 3. Hope you yeah. Note it down. Yeah. Correct. Okay. Application 3. There's a cart. Okay. There's a cart which is filled with sand. Okay. Moving on a smooth surface with initial velocity v naught. But the problem is there is a hole in this cart. So sands are falling from the cart. So this is mu kg per second. Okay. Good question. You have to find what you have to find. You have to find velocity of cart after t second. Find velocity of cart after t second. Solve by impulse momentum method. Solve by impulse momentum. No. You'll be shocked when I'll tell the answer. No, you'll be shocked. Same answer means whatever you got for previous one, same only, but it will be minus mu t. Correct? No. Yeah, mass is being lost, that's fine. But answer will be after t time, velocity will be. Yes, anyone? No. You do integration of f dt equal to change in momentum. External force is 0. P final minus P initial. So basically I can write P final equal to P initial. Final mass, final velocity equal to initial mass, initial velocity. Okay. Yeah, final velocity you have to find. See, 99.9% student, 99.9% student tells me the answer, sir, it will be ft by m minus mu naught into t. Because previous one I got this, na? Where is not ft? Sorry, m naught v naught. Sorry, not ft. So 99% student tells, as a initial mass you have to take m naught. Okay, initial mass is m naught. So 99% tells m naught v naught by m naught minus mu t, not mu naught, sorry, minus mu t. This is the answer of 99% student. 99.9 I told. Okay, only 1%, 0.01% tells the correct answer. See, no. Okay, see, final velocity will be v naught, will be, which is equal to initial velocity. I'll solve. See, what is final mass? Can I write capital M minus mu t, correct or not, into v final, plus whatever mass is falling, it's also moving with same velocity, na, v naught, mu t final velocity I am taking v final, it will also move with same velocity. That is equal to initial velocity, initial mass m naught, velocity v naught, mu t into vf gets cancelled. Okay, so m naught, initial mass m naught v f equal to m naught v naught. So vf equal to v naught. सर आपने मैथमेटिकली तो करके दे दिया, बट समझ में नहीं आ रहे. समझ में क्यों नहीं आ रहे? देखो, whatever mass is falling, don't think that its velocity becomes zero. See, if you drop any stone from a moving train, will the velocity of a stone become zero? If velocity of a stone becomes zero, then obviously the velocity of train will increase. Velocity of a stone is not zero, it's also moving at same velocity. So if in a condition whatever mass is falling, if it comes to rest, then I can say velocity of the cart will increase, because mass is reducing, velocity of cart will increase. But that's not the case. Here whatever is mass is leaking from here, sand is leaking, that is also moving with v naught, that is also moving with the velocity of cart. So there is no change in momentum. See, that may come to rest after striking the ground and all those things, but when it is leaving the cart, it's having same velocity, no? So nobody is changing the momentum of the cart. Now when the sand is got separated, then it strikes the ground, then its momentum is changed. But when it is leaving the cart, its momentum is not changing. So momentum of the cart won't be changed. Okay, is that clear? So momentum of the cart plus sand, sorry, I told cart plus sand won't be changed just when the sand leaves the cart. Okay, so velocity will remain v naught only. Clear, all of you? Yeah, because because it's adjusted, whatever power is needed, that much only it is given. Whatever force is required to move certain mass, that much only it's given. So it's always, there is a, I think, stabilizer, something like that, which always keeps the velocity constant. Okay. No. Then power delivered will reduce immediately. Okay. Power delivered to the conveyor belt will reduce immediately. There is some no. There is some mechanism. So that mechanism I'm going not going into it. But its velocity, they maintain the velocity. No, velocity remains constant. Okay. Okay. Now the same problem. See, first we did two problem. First problem, what I told, mass is dropped, velocity is v naught. Second application, what I told, application 2 I told, mass is dropped but given a constant force. Now third application I told, mass is dropped, velocity is constant. Now I'll give mass is dropped and force is also applied. Application 4. See, whatever we are doing now today, after going home you should revise it and try to derive it yourself. Otherwise, no, you'll forget, you'll face difficulty. All of you should derive these 4 applications and rocket propulsion result by yourself. Okay. Constant force is applied. Mass is m naught initially, sand. There is a leakage of sand which is mu kg per second. Mu kg per second. Okay. So here I am giving initial velocity is 0. Force F, this constant force, constant force F is applied. You have to find velocity. This surface is smooth. Velocity of cart. This is mass of sand plus cart, m naught. M naught is sand plus cart. Initial mass. Initial velocity u is equal to 0. You have to find velocity of cart after t second. Okay, this is what you have to find. All of you solve this. Yeah, correct. Ft by m naught. No. Use this formula. F, because force is applied, na, F equal to m dv by dt plus v into df by dt. Use this formula. Impulse also you can use. Why I am telling you to use this formula? Because it's a variable, like velocity will vary at every time, correct? You can use both only, that also fine. Yeah, you'll get in terms of ln. Tell me. If, tell once again, where is ln then? Acha, ln? No, 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 no. I'm writing the answer. Please check. F by mu ln of m naught by m naught minus mu t. So F equal to m will be what? M naught minus mu t at any time. Mass is what? M naught minus mu t into dv by dt plus 0. Sir, why you are taking this 0? Because this falls down, na? Falls down, correct? So when it falls down, do I need to apply a force on this? No. So what it will do? It will provide some thrust force in the forward direction, I can say. Okay. Yeah. I'll tell you one thing. Yeah. F dt by integration of f dt by m naught minus mu t, correct, equal to dv 0 to v. See, I'll tell you one thing. Whenever you have integration of dx by a plus bx, okay, how to do this integration? What you do, you take a plus bx equal to p. So differentiate, partial differentiate both sides, you get dx equal to dp. So finally your format is b dx equal to dp. So dx equal to dp by b. dp by b. dp by b. Yeah. So now you replace dx by dp by b. So I'll write 1 by b outside by p. So 1 by b ln of p. So here, what is the coefficient of t? Minus mu. So you just write minus of 1 by mu into ln of force, keep as it is. Okay, force outside the integration. ln of m naught minus mu t. Okay. From where to where? 0 to t equal to dv is v. Okay. So whenever you have integration a plus bx, so you just take coefficient of x outside as 1 by b. So here coefficient is minus mu. So I took minus 1 by mu outside. Okay. Clear? So now you will get f by mu minus ln of t, put t. So you get m naught minus mu t divided by t0 m naught. So minus, you just reverse that, equal to v. So you write f by mu ln of m naught by m naught minus mu t equal to v. Clear? So this is the answer. Okay. How much time is left? 15 minutes. Clear? So I think what is the last beginner box in this chapter? Beginner box 6 or 5? Yesterday what we are doing? 4 or 5? I think beginner box 6. Check. What is the last beginner box? So beginner box 6 we'll do today. Okay, we'll revise this and try to solve beginner box 6. So you can directly go to beginner box 6 only, okay, after the class. Okay, because today you don't have to travel to Allen, so your time is saved. So directly go to beginner box 6. Okay, and try to solve. Whenever you have some difficulty, refer my note, whatever today I taught. Okay. Done, all of you? Shall I proceed to next topic? So 4 application I told. Remember this 4 application. Then last topic for today. Okay. Chain problem. Okay. So question is, chain of uniform or not uniform, linear mass density mu, linear mass density equal to mu. So this is uniform chain. The linear mass density is constant. Uniform chain. This chain is uniform. Mass density is mu. Is lowered with a speed v. Find reaction force offered by the ground after chain has fallen through distance y. Okay, what is this question? Question is, there is a chain like this. Okay, so at t equal to 0 it is just touching the ground. T equal to 0, just touching the ground, it is lowered with a velocity of v. I am lowering this chain with a constant velocity v. Suppose I am holding at the topmost point, I am lowering that topmost point by a velocity of v, constant velocity v. So what will happen? After some time the chain will be like this. Correct or not? Correct or not? It will be like both side only. It has fallen through some distance. Okay. What distance it has fallen through? It has fallen through a distance of y. When it has fallen through a distance of y, what is the normal force or reaction force from the ground? And there is thrust force, I can write, from the ground. Okay, clear? So how to solve this question? Listen carefully. So when it has fallen through a distance of y, part of the chain is here. Okay, fallen through a distance of y. Here, suppose mass is m dash. So m dash g, there will be normal force upward. Correct or not? Okay. On the ground, thrust force will be thrust force will be down. So I have written here wrong. This won't be thrust force. This is normal force. Sorry, this is normal force from the ground. Huh? This normal thrust force will be on the ground. Thrust force. Okay, is that clear? What I have to find? I have to find reaction force offered by the ground. Basically, I have to find normal force. What is the normal force? So what will do? Chain will provide some thrust force on the ground. Chain will provide some thrust force on the ground. Okay. And I can write this equation Ft thrust force plus m dash g equal to normal. It's fine or not? Absolutely fine. Nothing is wrong in this. Okay. Clear? Okay. So we need to find thrust force first. Thrust force will be how much? Can I write? Force, any force I can write m into dv by dt plus v into dm by dt. Obviously I can always use this formula, correct? M dv by dt is 0 because velocity is not changing. This chain is lowered with a constant velocity. So thrust force will be what? V into dm by dt. V into dm by dt. Correct? Okay. What is velocity? Velocity is y by t. Correct or not? If it has taken t second to fall, I am lowering with constant velocity, that v is given. So y will be what? Y will be v into t. Correct or not? So velocity I can write y by t. Absolutely fine. Velocity is y by t. Okay. Clear? So what is Ft? Ft is v into dm by dt. What is dm? Dm is mu into y. Do you agree? How much mass has fallen here? Dm mass or m dash basically, that is mu into y na, because mu is mass per unit length. So for y length, what is the mass? Mu into y. Correct or not? Okay, that is only m dash. Okay, clear? Okay, so dm, how much mass has fallen? V into dm by dt. Mass whichever has fallen, that is m dash, that is m. Dm by dt is basically okay, mu into y. Clear? Is this clear, all of you? Yeah. So thrust force can be written as v into dm by dt, v into dm by dt. Dm is mu into y and dt is time t. So I can write mu into v square. Thrust force. Thrust force is mu into v square. Okay. Is that clear? अच्छे से समझो. ओके सर, हमको ये नहीं समझ में, सर आपने dt से t कैसे ले लिया? वो तो dt था, डिफरेंशिएबल क्वांटिटी था, आपने t. See what I have done in dt, basically 0 to t second. I have considered that in t second it is falling through y distance. Okay, so then it will be y by t. Okay, so thrust force is mu into v square. Now let us try to solve. N equal to what? N equal to m dash g plus thrust force. What is m dash? M dash is mu y na. M dash mu into y into g. plus thrust force is what? Mu v square. So normal force will be, you take mu outside, okay, gy plus v square. This is the normal force. Okay, m dash is mu into y. That is dm only. That much mass has fallen. Okay. Is that clear, all of you? Yeah. So this is the normal force. Okay. Next question. Any doubt, anyone? Yes? Others? Fawaz and others? Any doubt? Rasika, any doubt? Okay. Next question. Chain released from rest and comes to rest after striking ground. Find force exerted on the floor. Okay, there is a chain, again the same thing, it is just touching the floor initially, mass m, length l. Okay, it is just released from rest. So whenever it is striking the ground, it comes to rest. Okay, immediately after striking the ground, it's come to rest. And just remember, this is the condition given. Okay, you have to find force exerted on the floor. Okay, so basically whenever chain is falling, what is happening? Whichever part is falling, that part exerting some force on the ground and it comes to rest. But the problem is all part will not fall with the same velocity. The topmost part, this part will fall with highest velocity, maximum velocity. Lowermost part, which is just touching, that velocity may be 0. Okay. So you understood the problem statement, and I told also that all part will not fall with same velocity to the ground. So whatever velocity it is falling, suppose it is falling, dm is falling with velocity v. So dm by dt into v, that will be the force by dm part. Force by some other part will be some other v. So you have to find what is the force exerted on the floor. Solve this. This is force on dm, है ना? Find the force exerted on the floor. Two mg, 2 mg x by L, that is correct. That is momentum transfer to the floor. Also there is a weight, due to weight also, force due to own weight. Yeah, that is correct. That is momentum transfer to the floor. Correct. Force due to its own weight also you have to take. Yeah. Yeah, yeah, correct. Yeah. Let us consider a small element dx at a distance of x from the ground. Okay. So mass m, length l. So what is dm? Dm is m by l into dx. Mass of dx element. Mass of dx element. Correct. Okay. When this dx element falls, if this dx element you take, if it falls on the ground at a height of x, na, with what velocity it falls? Velocity will be what? Root of 2gx, correct? Yes or no? Okay. So force on the floor due to dx element. Force, when it falls with some velocity, it comes to rest because of that force. I am asking. So that force will be, F will be what? V into dm by dt. Correct or not? V into dm by dt. What is V? V is root of 2gx into dm by dt. Dm by dt is what? M by L. Dm is m by L dx by dt. What is dx by dt? Dx by dt is also V. Yes or no? Dx by dt, rate of change of x with respect to time, is V. That is also V, no? Okay. So can I write m by L root of 2gx whole square? Because this is also V, which is equal to root of 2gx. Correct. So this is F1 I am writing, F1. F1 equal to m by L into 2gx. 2gx. Okay. So let 2 mgx by L. Correct. This is F1. This is momentum transferred to the floor. This is momentum transferred to the floor because of that mass. Okay. Then what is the force due to own weight? Force due to its own weight will be what? Yeah, correct. mg, capital M. Its weight is mg x by L. When that x part is falling, due to that x part. Okay. So total force is what? Total force can be written as F1 plus W, which is equal to 2 mg x by L plus mg x by L. Okay. Is that clear? Due to falling of that x part, if totally it is fall L part, so it will be mg. X will be, you have to take L. So F equal to what? 3 mg x by L. So net force will be 3 mg, correct? When fully falls, you have to take that x equal to L. Clear? Force due to own weight. This is for own weight of x part. Okay. Is that clear, all of you? Wait, 6:36, you have another class. So I'll share the note. Okay, all of you understood? I hope all of you understood. चलो फिर bye. Shall I close? Yeah. You have again another class. Bye.